Hi, everybody. Welcome back. Chris Cauldron is back in the house. Welcome to his talk, Build a RAG Pipeline with Red Hat OpenShift AI and OPEA Validated Platform. Now, in case you missed his talk yesterday, we have recorded it. His talk is the full circle developer experience using Podman from AI PC to OpenShift AI. Let me go ahead and tell you about Chris in case you just joined today. Chris Cauldron is an enterprise technical solutions architect at Red Hat Tech Sales, working within the partner ecosystem to support Intel's AI and enterprise initiatives across North America. With a decade of experience in technology, consulting, and enterprise engineering, he has worked across healthcare, retail, energy, and government sectors. Prior to Red Hat, Chris was a technical consultant at Philips Healthcare, specializing in enterprise architecture, networking, edge computing, and ML apps. Over to you, Chris.
Thanks for that, Susan, and thanks everyone for having me back. Like Susan mentioned, I was here yesterday talking about our full circle developer experience using some of our platforms like Red Hat Enterprise Linux AI and of course our OpenShift AI. You guys probably heard a lot of us in the industry because Kubernetes seems to be the forefront of a lot of the solutions today inside the enterprise. And today we're going to talk about one of our other big partners aside from Intel is OPEA. We've done quite a few sessions with them. As you guys know, they are a framework for AI kind of enterprise scalability and infrastructure. We take a lot of the designs, bake them into our solutions, and show this to our customers. And of course, all these wonderful talks and trade shows alike. I've been on the Intel partnership for probably a little over a year now, working on integration, joint solutioning, go-to-market sales, and a couple things. So we always try to bake in our real-world examples into any demos we do, really trying to showcase how we can affect enterprises and businesses at scale using AI and our products. So kind of jumping in, chatbots seem to have been the first real mainstream pop culture-esque kind of example of AI. ChatGPT and OpenAI brought forth, some tooling that everyday people can use as an application and even on their phone or desktop, wherever have you. And it really kind of introduced AI as a strategy across the industry. AI is kind of seen like magic a little bit, right? But it's just math. It's just an application like any other kind. It takes a few extra steps. It's very, very data intensive and of course resource intensive, which makes it kind of a business challenge now for a lot of customers. The barrier to entry seems pretty high. So any way we can make that a little bit lower, a little bit more efficient for our customers is ultimately our goal. Of course, AI has a couple of other strategic ways of being used across the enterprise, but it seems as if the low-hanging fruit today, the one that customers are adopting a little more quickly, I'm not saying it's the most impactful for revenue retention, things like that, but it definitely seems to be the slightly easier and more approachable one because we have a lot of third-party ISVs like Hugging Face and a couple others that are really bringing models that out of the box can serve as a pretty great chatbot instance, these LLMs, right? But now we're trying to find a way for developers to be able to use their own data sets, bake them into these models, and start using enterprises as actual internal strategies, right? Instead of just a general purposed one. There's also just the issue of once you deploy this model, how do you maintain it? Do you just retrain it? What are the business best practices? And so by being able to kind of provide business accelerators and show how we can save money on consuming AI and entering it, and ultimately also mitigating some risk, right? Because moving workloads onto these is a huge upheaval. We're now having to expose data sets and reformat them for our applications to be able to kind of access them a different way and sort them a different way. And so there's also confidential computing that kind of jumps into the strategy of now. So relying on OPEA and these other frameworks are really crucial because we're all in this together. We're all going towards the same kind of end goal here. And so having these validated patterns really brings a lot of really good benefits to our customers. I did mention it's not magic, it's just math. We're just going to be treating this as if it's just a regular workload. So, as developers, we're able to see that this is just like a workload like any other, but let's kind of break down some of the steps. This is, of course, some more information on OPEA and how we're using a RAG database to kind of enhance our operational lifecycle of application and their delivery. instead of having an LLM kind of just exist as itself out of the box, untrained or fine-tuned, we found another methodology of introducing a RAG interface, right? Being able to resource a adjacent database, so we don't have to continue retraining the model. Instead, it has a place that can go and reference this information and continue the life cycle that way, because retraining and inferencing takes quite a big toll on the data center itself. This is much more of a standard workload where we can reach and get a database, so what that way provides a little bit more dynamic knowledge. And really, it's only adding one step into the retrieval process for an LLM, where typically you're comprised of around 5-ish steps from the query to pulling it down to serving it, etc. This is a much more efficient way to use existing databases, existing things to leverage their data sets. And again, developers kind of play in these first two boxes, the idea of prototyping, building, and refining. And at the end is where we're going to operationalize this. So this framework actually helps for all of these sort of steps. And using our platform, we have out-of-the-box tools to kind of help also empower developers to be able to try things quicker, fail a little more quickly, refine it, and ultimately deploy in the data center for everybody to use. Red Hat, if you guys weren't aware, is an open source company, meaning that we invest heavily into open source projects on the upstream. Our Red Hat Enterprise Linux is based off of that. It used to be our flagship. It's based off things like Fedora and CentOS Stream and things like that. We've done the same thing with OpenShift AI, where we've contributed to all these projects. Not only do we sponsor them, but we also contribute ourselves. And by being able to kind of piece together all these upsource open stream projects, we're able to create a more robust enterprise solution instead of having private IP kind of guide the way that we, our product kind of roadmap. We actually have the same community base that has, maybe new fun, crazy ideas that could serve an enterprise at the end. So it's much more of a crowdsourced kind of approach, right? This also helps us kind of take the DIY out of companies trying to do this themselves, right? So a lot of these upstream projects don't have support. By getting a Red Hat subscription, we bake these all in together, harden it, and make it an out-of-box experience that still provides that security where it's one-click updates, it's fully integrated, and all the support that you really need to run it. And so we're proud to have also partnered with Intel to provide some of these out of the box with OpenShift AI, to just mention a few. These are some of the components that come with OpenShift AI sitting on top of OpenShift, where you still get to use all the regular operators. You get to use the underlying API and functions like GitOps and some of the pipeline features, even service mesh, and of course all the observability and monitoring that you get from it as well. But on top of it, OpenShift AI opens as its own console view and has insights into its own observabilities, anything from CPU to HTTP requests, things like that. You're also able to create workbenches and projects and have them be seen in OpenShift as a regular object as well. A workbench is where you're going to do the majority of your work, and we've introduced some of the most popular frameworks and notebooks and runtimes for developers of any walks of life to feel comfortable in this new environment. We're really just trying to create the house. You can look at it as a house who's kind of plumbed for solar, has the ability to plug in an EV charger. You bring your furniture, but you're familiar with all the same places it's supposed to be. And again, taking the DIY out of it, serving it all up as a one inclusive solution with all these nuts and bolts with support. So for example, part of the workbenches is creating like a notebook image, whether you're used to working like VS Code or Jupyter Notebooks. You're actually able to store all your code in repository, whether that be a Python script or what have you there in a Lyra script. You can have that sitting within your Jupyter Notebook and have it execute within the OpenShift AI environment, since it is tied to on the back end through an S3 bucket or whatever storage you'd like to plug in. We have connections to a couple different versions of that. We're also able to do distributed workloads through things like KubeRay, spin up an array cluster, help it distribute it on its own, and that acts independently of OpenShift. So allowing you to strictly have your AI workloads be distributed for your data scientists to be able to use perhaps underutilized nodes and things like that. We also have the model serving features to like K-serve and model mesh. So we're actually able to serve these in containers, making it a lot more lightweight, making it a lot more elastic, and again, being able to deploy it kind of anywhere and get the same experience. With the help of Intel, actually, we've served a couple of popular runtimes, including OpenVINO, and this is completely available out of the box, allowing you to get started immediately, create an actual model server, and use OpenVINO as a runtime. And I did mention all the monitoring that you get as well. So a few of the things there, we'll dive in a little bit deeper. I was talking about the notebook images, being able to kind of bring in your own and run it. And this is all namespaced, meaning that you create a data science project, and that is your single project. You can assign role-based access control to that single project and have all different types of developers working with their own sort of permissions, allowing them to work independently or together. In the deployment, you're actually able to create templates, so you can one-click button create some of these deployments, right? So it's pre-allocated your CPU and memory, or you can go in and change it, of course, to the YAML or through some radio buttons. We really try to make it as easy as possible. So if you're using like a GPU accelerator, something like a Gaudi, we actually have one-click buttons that are integrated fully through the partnership where just click, I want Gaudi 3 accelerator, automatically assigns it to it. You don't have to go in and change code. You don't have to remove different variables inside your YAML or inside your code. It's all pre-done in the back end here. And of course, connecting your cluster storage is easy as one-click button as well. We really try to give developers and operation people the option to do the same thing 2 different ways, whether you used to work in the CLI, whether you would prefer to kind of introduce a GitOps function where you're creating like webhooks and triggers. So if you want to change a repository as a single source of truth and you're used to working in that format, absolutely you can. Or for people that like a GUI or a much more friendly interface, maybe a level 1 or 2 admin that doesn't want to break out the CLI or doesn't want to have to learn a whole new trade, we have very friendly functions that all tie in through APIs and do the same exact things. So really trying to be able to give people comfortability and the confidence to be able to work on AI out of the box, because it really is not that hard if you treat it just like any other workload once you get past that conception. This is just the physical representation of kind of what I just said, where if you're used to working in UI or YAML or anything like that in between, you're able to kind of plug it in and run it very, very much similarly across the environments. And again, even things like data science pipelines, you might have seen on the previous screen, where that is more of a GitOps function, right? We're going to try to automate parts of the application development lifecycle. And in this case, we're talking about AI development lifecycle. So this pipeline actually sits outside of the regular OpenShift pipeline. Because if you're to launch a regular OpenShift Kubernetes cluster, whether you're using virtual machines or just containers, you have your own pipeline features there. Since OpenShift AI pops up above OpenShift in its own console view, it really is segmented to its own area. You're able to pull in a completely separate pipeline. And in this example, we're going to go through a few screenshots of a demo we did. We actually pulled this pipeline from our Jupyter notebook, right? So it's code that we're deploying into OpenShift and executing within OpenShift AI as a container, meaning it's all one place. You don't have to secure the 3 different places. You don't have to worry about creating a layer 2 or layer 3 VPN out or any tunnel or any subnetting. It's all the execution environment lives within OpenShift AI. And we're actually able to define multiple steps to kind of automate that as well. So you don't have to, do it 5 different ways, 5 different times. It runs an automation job and it runs within Jupyter notebooks. If you want to do your checks there, import them into OpenShift AI and then actually deploy them in OpenShift, you can do that as well. Create more of a test and dev environment and then create your production environment. And quote unquote, I said that kind of loosely because you can do your checks and things like that. If you want to try different forms of inferencing as well, you're able to do that, execute within Jupyter Notebook. Doesn't mean it will execute in the real environment unless you set those parameters. So good segmentation. And I did mention it sits above OpenShift, it installs as an operator. So this means that anything that you create within OpenShift AI will automatically be viewed in OpenShift as an object, but you still have that segmentation of console view. This allows operation teams, storage teams, and network teams to still be able to manage OpenShift AI as its own separate environment and kind of tie them together. Because again, it is a workload like all the others. OpenShift AI is where we're going to be doing a lot of the inferencing, training, and model development. But ultimately, once you have that model, it's going to deploy an application. So being able to have this seamlessly pop up in OpenShift automatically allows you to be able to reference it a lot easier, do that one-click update. Now you can deploy an application, pull that PVC or that storage bucket from your data science project and deploy it like an application, and it's still leveraging that server that you're serving the model on. So very, very cool that way. Now I give you kind of a background on some of the components, nuts and bolts, and the way that OpenShift AI works. Kind of diving into now the actual demo we did. Intel being a huge partner of Red Hat and alike with us and them, we've been at a lot of trade shows around the world now. And I was lucky enough to help present with this last year at our Red Hat Summit, which took place in Denver, I believe, last year. Where on the show floor, we created a recorded demo and a live demo of this, where we put 2 chatbots against each other using Intel Gaudi. OpenVINO framework, and of course the OPEA framework, and the OpenVINO runtime, to be able to shoot out two different chatbots where we had them, one of them using a RAG database, one of them just talking by itself, to kind of demonstrate in real time the benefits of using RAG. And we showed the steps as to how easy it was to create this using OpenShift AI and Gaudi. All right, so chatbots, as you guys know, use a backend LLM, which is a general model, and RAG offers the ability to add context to a situation. So if you start with a prompt, that LLM or that model is going to kind of generalize and try to assume what you're trying to get it. Let's say it doesn't have all the information, or maybe the neural network that makes it up doesn't fully understand how to answer this question. It will start to hallucinate. It will start to give a general answer that's not super specific. And if you've ever noticed someone try to type like a ChatGPT prompt, like on a LinkedIn post or something, you can kind of tell it's written by an LLM because it has its way of speaking. As we make these smarter and introduce our data sets, we can kind of make it seem a little bit more real, a little more pertinent. And besides just that contextual view, it actually just adds a lot more simplicity where you don't have to continue to retrain that model every time you want to introduce any new data sets to it. That takes a lot of money, it takes a lot of time. It's completely unnecessary. By referencing this RAG database, we're able to add context, stop the hallucination of these models, hallucinating again, coming up with these generic, vague answers, and we're able to apply a lot more depth of conversation and context, and ultimately use our own data sets for it. So quite amazing. Here's kind of the design of our demo, the way we created it. I mentioned we have the same application on two different formats here. One of them is using the RAG backend, and one of them is not. And we're executing the exact same prompt on both, so that's the way we kind of want to observe it. We're going to be showing 4 applications, and 2 of them are going to be the database, one of them is going to be the UI, and the other one is going to be the actual the serving of it. So just kind of showing a high-level view of how this is not necessarily a production scale, but this is, you know, kind of in a lab, how we're using it just to shoot these things out. But it's all run locally together out of OpenShift AI. You have your documents in your database as a connection through like an S3 bucket, things like that. And of course, all working within the same console. So here is our regular OpenShift UI. And what we wanted to show here was some of the operators we had installed. And a lot of these things are out of the box. But an operator you can think of as downloading an app on your phone. If, let's say, you want to go to YouTube and you have an Apple iPhone, you open up your Safari browser, you type in YouTube, and you're on YouTube, right? But kind of looks a little weird, doesn't look completely seamless. So, you know, if you were to go to the App Store and download the app natively onto your iPhone, it runs a lot more seamlessly. It's fully integrated, right? And that's the way you can think of these operators, instead of stitching together, you know, an application through some other web browser, something like that, which it will work. You know, the operator allows you to work within the console view and just provides that integration, and it's all supported through SLAs between the 2 companies. For example, the first operator on the screen there is the Habana AI, which is developed again by Habana Labs and Red Hat together, and continue to, you know, release versions of that. So you can have those one-click buttons. Now suddenly you'll have a radio button that shows up where you're actually able to add accelerators and things like that. And yeah, so OpenShift AI installs exactly like that on top of it. Again, now in that kind of integration. So we absolutely recommend running the Gaudi operators into OpenShift to be able to use all the benefits. We were talking about the runtimes. You're able to bring your own, or of course, select the ones that are preloaded on here. We have this text generation inferencing on Habana Gaudi enabler here that we have to be able to, you know, have it be out of the box. Of course, you have all these other ones like OpenVINO and CalKit, things like that. And it just adds accelerating that. These live as profiles within the actual console. Again, making it a lot more friendly. Yes, so you can create profiles, is what it was pretty much saying. Yeah. And this is that one radio button that I was talking about. You have your profile, your accelerator, you drop in your Gaudi, and it has the one-click button to run this workload with it or not, right? So just providing it out of the box. This normally would take a lot of backend function to make work in a DIY or perhaps even a single VM environment. We brought this kind of out of the box to help get you kind of kicked off a little quicker. Now here's our view within OpenShift AI, which you were looking at before was our OpenShift environment as well. We've gone up to the data science projects, which I mentioned is going to host. It's a data science project is mostly like a namespace. Think of it like a little folder you're creating, and each application or each quote-unquote project is going to be its own data science project. And within it, it's going to live things like your workbench, your cluster storage. That's the same view you had before. And so in this example, we're using, let's see, data connection of object storage. So you're of course able to create as many connections as you want to anything, whether it's a URL or you're using your local storage or maybe a shared storage to be able to run. So in this example, we're going to be using a database to run this object storage. And here are the workloads that we're going to be using. I mentioned the 4 applications and then your database. So this is going to be our RAG and not RAG approach. This is the backend, the business logic, the actual files and things like that that we're running for this. And again, these are running as containers within OpenShift because we created the data science pipeline, the data science project in OpenShift AI. Those are going to automatically reference these because they're seamless in the backend. So this is showing them running as container on our actual cluster. And this is going to be our database, right? And this is what we preloaded with some contextual data. This could be anything from, text documents to, receipts to whatever it is that your business kind of needs. In this case, we're actually adding context about Red Hat Summit itself. We have some of the things about some of the people that were on the show floor and some of our other good friends that work on the partnership and things like that. And then, of course, we're going to need something to actually click. So we created a nice little GUI and UI for us to be able to interact with the model itself. Now, we made this side by side here. On the left, you're going to see your stock model without any database referencing. And then on the right, it's going to show what the result's going to be with your actual RAG implementation. So, for example, one of the prompts on the left on the untrained model, or the model without the reference, is when does Red Hat Summit take place? And it shows. Actually, let me show you a different one here. That third question there shows, are there any sessions hosted by Sridhar? Sridhar, a good friend of mine, also on the Intel partnership. And it says, I don't know, I'm not aware of any sessions hosted by Sridhar today. Could you provide more context or clarity? It's kind of hallucinating a little. It's trying to, fish for some more answers. And then on the right, if I remove that first part of it, the answer on the one referencing the RAG database, when we have our data sets, shows yes, he will be hosting 2 sessions. Adds more context, shows more specificity, and we didn't have to retrain the model. It just references database and pulled that information forward. And it's all by adding 1 extra application using Redis to be able to serve that to it, right? It's the same exact model using the same application, and it's just referencing a database. One is not. It's 1 extra step. You can add that into your actual pipeline features to be able to serve it. Just makes it that much easier, right? So that's kind of what we showed on the floor. And here's another flow of this. These are the multiple steps that your RAG database is going to take, and the way that you're going to query and pull that request down. So this is a good little screenshot to kind of show some of the nuts and bolts of how that's actually working. And again, we pulled this all from OPEA, and I'll go into a little bit more about OPEA a little bit later here. But just kind of showing what we did and how the inferencing of it was just that much easier. We didn't have to retrain anything, right? Again, this is all using Intel AI Accelerator to create these prompts, and we're serving this through the S3 bucket, like I mentioned. Now, this is kind of the blueprint that we took from OPEA, right? The way that we're going to load the database and position it, and even some of the networking functions that we're going to put behind it. It's all using the pod-to-pod networking. We didn't have to introduce anything special. It's just using your regular layer 2 pod connectivity, and that's assigned to the namespace. Every namespace gets an IP address, and these pods share that and create their own subnets within it, right? And so just kind of showing you some of the steps here and some of the guardrails we put for us to be able to do executing prompts a little bit more efficiently. And using the RAG, we're actually able to kind of put in a little bit more specificity in some of these tasks as well. So this is the official one that we got from OPEA into the website, and it shows some of the features that out of the box they have as well. These are references that are public. You can absolutely go to the OPEA website, and we recommend that you do, so people to look at this along with a lot of other examples. And it's fully integrated. There's not necessarily any software you have to pull down from it. Again, this is just a reference architecture, if you will, to kind of show you the way that they have developed it. And this is all community driven as well, to give you a better idea of how people are doing in the real world. The reason we like partnering with OPEA is it's very open sourcey that way, right? We're using the community to kind of bring forward a like-minded goal. and develop it together, right? So we're hoping to push OPEA, and we've been showing OPEA at a lot of our trade shows just because, they know what they're doing, and we love, using their references. And we loved it so much that we actually started breaking this into something that we have. We have our own registry or website, validatedpatterns.io, which we sponsor, which is our repository of reference architectures that have been proven either through customer implementation or during a product development. And these reference architectures are completely free. You're able to look at them at things other than AI as well. But we followed kind of in suit in that, and we've actually uploaded this exact same reference with the chatbot model into our OpenShift validated patterns. And this is that website for you guys to refer back to if you guys ever wanted to. We have a lot of things here as well. We're continuing to add to them. This is just one simple example of an LLM. We're going to be going into a lot more deeper ones this year. So please keep an eye out for all the new announcements that Intel and Red Hat are doing together. Anything from model serving now to fine tuning. And we're also going to be deploying some other models like our Granite model, which is released as part of our Red Hat Enterprise Linux, which is an open source model for you guys to be able to use. We have some labs around InstructLab and Podman, which I talked about yesterday, which is our static workloads. But hopefully you guys kind of got an idea of how easy it was to kind of deploy this. A lot of this stuff is available if you want to try it for yourself. We have a canned version of this demo as well, which we're working on being available in our Intel Developer Cloud. So if any of you guys are interested in learning a little bit more or testing this out for yourself, we have uber amounts of trials for OpenShift. We have developer clouds and, sort of instances where we can populate an environment of your own and you can test this out yourself. Our talk yesterday, hope you guys go look at that. We have some resources for you guys to be able to try this with your own data sets, run this locally on your laptop, and be able to kind of play around with LLMs without having to spin up costs in the cloud and run it locally on your computer. And you can have fun putting your own data sets against it as well. So hopefully I showed a few of the out-of-box features, the one-click buttons that you're able to apply to it. That's all I have for you guys today. I implore you guys to please check out OPEA as well. Great partner of ours. If anyone has any questions, you have an answer.
Hey, Chris.
Yes.
There was a question about, could you post the link to the GitHub links with the Jupyter notebooks in the chat? And since we have time, if you want to even go to that GitHub repo and just walk through the notebooks, not to put you on the spot, but you are welcome. You are welcome to do that, because I think that would be very appealing to this audience, please.
Yeah, let me see if I can pull it up for you guys. I don't know if it's still to it.
And again, the request was to go ahead and put the link into the chat, because I think some folks would like to go ahead and take a look at those.
Yeah, let me see if I can find out which I could. Let's see. If I'm being honest, we're actually editing it for a new show. We're doing Intel Vision here in a few weeks in Vegas, so I think it might have changed a little. But is there a way I could get this onto the deck and perhaps have this available as something? I don't know if I'm going to be able to pull it up immediately right now.
I think we can do that. I need to figure that out. I need to figure that out, how to do that, Chris.
If anyone wants to reach out to me directly, you're actually very welcome to do that as well. Yeah, I just got the question coming here. Yeah, if you guys want any resources directly, I'm happy to send them to you guys once I find them here. Apologies, I didn't have them on hand for you guys.
Chris, do you want to put your contact info in the chat? How you want people to reach out to you?
Yeah, absolutely. Let me. I submitted it as a question. I'm also going to put it in the speaker chat here.
Yep, I see that.
Perfect. So yeah, everyone, please feel free to reach out to us. We're happy to have any conversations or just talk about AI in general, even if it's not enterprise ready. I'm happy to share our thoughts and details on it, and I will for sure get this GitHub link from one of our canned demos on this if you guys wanted to try this out. But I would really implore you guys to go into the Intel website, look at the Intel Developer Cloud. We're loading a lot of these demos into that instance that runs on top of OpenShift, and we support them as the partnership. So we're hoping to have a lot more CAN demos for you guys to kind of try this out, because unless you have your own, databases and clusters to run this, it'd be kind of difficult to do it. So happy to share the code just for reference.
Chris, do you know when those notebooks will be loaded onto Tiber?
Fortunately not. Our CEO is actually meeting with the Intel CEO, I think this week, or sorry, early next week, to figure out some of the fine details, which is super exciting. So, yeah, part of that.
That's good. That was a question that came in, and let's see. Okay, GitHub and your contact. And there was a question about, are there any upcoming trainings in regards to RAG pipelines and OPEA that you all are doing?
Trainings as in like a workshop sort of thing. So
I'm going to interpret that as workshop, webinar.
So we definitely will probably have some webinars coming up. OPEA does them all the time. I don't have any scheduled myself. But if you go to the partnership page for Intel and Red Hat, whether you just type it into Google, like Red Hat Intel partnership, we have a big list, I believe, there for some of the upcoming events. We do road shows as well that Intel sponsors. So we're looking at starting up an AI roadshow. Last year, you might have heard of a virtualization roadshow. We're looking at kicking this off this year. We're going to hit multiple cities across the country of the United States, and have customers be able to come in and register for free to have a half day of learning, and we'll bring laptops out for you guys to be able to try this out yourself as well. So look out for that in the near future.
Okay, I don't. Just checking the chat again. Okay, no new questions on chat and Q&A. I don't see any additional questions either. Chris, is there anything else that you would like to show?
No, I think I covered it. Thanks again for having me. This is awesome opportunity. Hope you guys were enjoying the whole week here.
Yep. Okay, great. Well, that's the end of our Q&A. And Chris, thank you so much for being with us today and yesterday. So again, just a reminder for you all, there is Chris's talk from yesterday, which is really more of an intro to Podman. And then today is his more advanced talk where you can get into the Jupyter notebooks and things on the GitHub repos, etc. So up next, we have the talk Building Agentic LLM Workflows with AutoGen by Darren Yonda. So I will see you in the next session. Thanks again, Chris. Really appreciate it.
Absolutely. Thanks, everyone.